I am Vagyalakshmi, Department of Mathematics, SNS College of Technology. Today we are going to discuss about the convolution theorem based we applied in the Z transforms. So the first we can see that convolution theorem is Z inverse of f of z and g of z. If we want to write it as two functions, if it is two functions, separate the Z inverse terms, and then when you are applying the formula, you get in terms of n, and then in terms of n is the first function should be right with the we are changing as a discrete function. So that is k equal to 0 to n terms we are applying, and the first function we are write it as k, and second function we are changing as n minus k. And after this, when we are expanding the series, you get this series like 0 to n terms you get. So for this series, you get replace 1 minus x to the power n plus 1 divided by 1 minus x. If we follow these 6 steps, and easily we can solve the convolution theorem based on that sum. Okay, so for check this sum, so z inverse of z square divided by z minus a, z minus b. So we want to check this sum if it is using convolution theorem or using partial fraction. Here it is using convolution theorem, we want to solve this sum. So same process we can do for the general partial fraction also. So I am going with the convolution theorem. So what is the first step is we want to split like two functions. So z inverse of z divided by z minus a into z divided by z minus b. I split it as two functions. So this two function is again we are writing as a separate z inverse. So which is equal to z inverse of z divided by z minus a into z inverse of z divided by z minus b. After this, check it, apply the z inverse formula. So what is the formula? Z inverse of z divided by z minus a, that is a power n into, and z inverse of z divided by z minus b means instead of a, b is given, so b power n. That means we got, when we are applying z inverse, we got the function in terms of n. So this n we can change in terms of k. Okay, for I am not telling about mathematically, k equal to 0 to n. So k we are changing here. Summation k equal to 0 to n. First function, that is a power n. Instead of n, replaced by k. So a power k into second function, instead of n, replaced by n minus k. So here second function is b power n, instead of n minus k we can replace. So this is the replacement. So next k equal to 0 to n a power k into, I am splitting this term, b power n into b power minus k. Why it is means this summation is only for k, not for n. So this one is a constant, take it out. So b power n is a constant, summation k equal to 0 to n a power k, and this minus k means it will come in the denominator. Both the terms are in the common power. So a by b to the power k, we can write it like this. After this, I am expanding this series. So b power n into any number, first k equal to 0, any number to the power 0 which is equal to 1 plus k equal to 1, that is the term 1 time will come, plus a by b to the power 2 plus etc. up to how many terms? Up to n terms. So plus a by b to the power n, you can write. Okay, after this, b power n, and check with this again, 1 plus x square plus up to x power n. So what is our x is? A by b. So instead of, we are going to replace by this formula. So 1 minus x. Instead of x, we are going to replace by a by b to the power n plus 1 divided by 1 minus a by b. So easily we can replace here. 1 minus a by b to the power n plus 1, the whole thing divided by 1 minus a by b, that is instead of x, we replace these values. Okay. So easily, if you follow these six steps, easily you can get a next step. After this, we are going to solve the basic examples. So LCM is 120. So b power n in the numerator separate 1 minus a power n plus 1 divided by b power n plus 1, and in the denominator take LCM b minus a divided by b, and you can write it as b power n, take LCM b power n plus 1, b power n plus 1 minus a power n plus 1, the whole thing divided by b minus a divided by b. Okay, so fraction, another numerator and denominator as well, all the terms having that same fraction. So b power n, and write this as a reciprocal term, and you can write it as b divided by b minus a. Okay, and then this term you can write as, this is numerator fraction, so you can write as this, that is b power n plus 1 minus a power n plus 1. Write in bracket, and the denominator b power n plus 1. Write as it is. After this base tables we can add the power. So we can write this as b power n plus 1 divided by b minus a into b power n plus 1 minus a power n plus 1. Write in bracket, divided by this b power n plus 1 we are having as it is. Now we can cancel these to b power n plus 1. After this, get a conclusion which is equal to b power n plus 1 minus a power n plus 1 divided by b minus a is the value of the z inverse of z square divided by z minus a into z minus b. Okay, so finally we got the result using convolution theorem. We got the result for this function. Here a and b, the general terms only given. Instead of a and b, you can replace by any value, 1, 2 or 3, 4, whatever it is, you can replace. Instead of a and b, you will get the answer. So here I did the general terms only. Thank you.